Good morning, everyone. Today we're going to be taking a look at complex numbers, and we're finally going to be able to take the square root, or really any root, but today we're focusing on square roots of imaginary numbers. All right, so this is when we have something like the square root of negative 60 or something like that. It's a negative number for your radicand, and so previously what we've done with that is we just said it's not possible. There's no real solution. And that's because there's two types of numbers. There are real numbers and then there are imaginary numbers. So within real numbers, it's right to say that there's no real solution. But there is a solution, and that involves an imaginary number. So I just want to preface this by saying that imaginary numbers are not fake numbers. I've read many articles and done some research, and a lot of people will agree that imaginary numbers were just very poorly named. It makes it seem as if they are fake, but they're just not real when it comes to what the word real means within the world of math. So they do exist, even though they're called imaginary. All right, so to understand imaginary numbers, let's talk about the definition. All right, so we use I, it's kind of a fancy like italicized I, to talk about imaginary numbers. And I squared gives us a negative 1. All right, so there's a couple different ways that we can write that. We can say I squared equals negative 1. Or we could rewrite this, if I square rooted both sides of this, I could rewrite this as I equals the square root of negative 1. So this right here is going to be really helpful to us when we start taking the square root of negatives. Before we even do that, let's try to understand a little bit about how I works, okay? So I'm going to give you guys a little bit of a key here. So I, of course, equals itself, but I squared is I times I, which I can't give you a good argument in the short amount of time right now for why, although I can send you plenty of articles that explain this, but I squared is going to give us the value negative 1. All right, now I cubed, the exponents still work the same as what we've been doing. I cubed could be rewritten as I times I squared, right? I times I squared, because the exponent here is 1 and the exponent here is 2, and we know that when we multiply like bases, we add, so 1 plus 2 is 3. And so by breaking it down this way, we can see that, all right, I is equal to I, and I squared is equal to negative 1. So when I multiply I times negative 1, I get negative I. So I cubed equals negative I. Let's take a look at I to the 4th. So a couple of different ways you could break that down. You could say I to the 4th is I times I cubed, or you could say that I to the 4th is I squared times I squared, and that's what we're going to do, because the I cubed one doesn't actually work out truthfully. So we have I squared, I to the 4th is I squared times I squared. Well, I squared is negative 1, and if we multiply that twice, we get a positive 1. All right. Now what happens after this is that everything keeps repeating. So for example, I to the 5th, I could rewrite that as I times I to the 4th. And so I is equal to I, and I to the 4th is 1, so I times 1 is I. And you can see that the 5th I value is the same as the 1st. Well, if I did I to the 6th, I would get this answer. If I did I to the 7th, I would get this answer. I to the 8th, I'd get this answer. This is something that we actually call modular, something I learned about in college, and it's basically how our clocks work. All the values repeat after a certain number set. So it's really interesting, like on our clocks, everything repeats after the 12 hours, right? Even though we have 24 hours in a day, we have two sets of what the 12 hours mean. everything starts repeating. So you have 1 a.m., but you also have 1 p.m., right? So once you know these first 4 I values, you can figure out any other I value after that. So that's what we're going to take a look here. What we're going to take a look at here. So anytime you have a value larger than I to the 4th, you want to try to extract, you want to almost like factor out, you want to try to take out as many I to the 4th sets as possible. So here for I to the 7th, I'm going to rewrite this as I to the 4th, and then what I'm left with is 3 more i's, so I have I cubed. The reason that I want to use I to the 4th as much as possible is because I to the 4th has a value of 1. And multiplying by 1 almost is as if I didn't even have it, right? I cubed times 1 is just going to be I cubed. So what we really want to do, although technically we're doing this, right? I to the 4th has a value of 1. I cubed has a value of negative I. So we end up with negative I, which is really just the value of this like leftover piece. All right, so you guys will find those shortcuts very quickly. All right, so here for I to the 20th, again, I'm going to start with I to the 4th. Well, instead of writing something like I to the 4th times I to the 16th, or I to the 4th times I to the 4th times so many times that until you get 20, I know that 20 i's is just 5 sets of I to the 4th. Okay, so I to the 4th equals 1, and if I raise that to the power of 5, I just get 1. So you can see 20 is a multiple of 4, so it has the same value as I to the 4th. Let's take a look at this next one. I to the 46th power. So if we're thinking about multiples of 4, the biggest multiple of 4 in there is 44. So I'm going to write this as I to the 4th. And how many sets of 4 do I need to get 44? 11, right? 4 times 11 will give me 44. But then I have 2 left over, all right? So here, I to the 4th is 1, and 1 to the 11th power is 1. So really the answer to this problem is just going to be whatever the answer to I squared is. So I squared equals negative 1. Part D is a little bit different. We now have a negative. Same rules as before when we were dealing with negatives. So I'm going to rewrite this as 1 over I to the positive 12th. The same way we would treat any other exponent that's negative. So now I'm just working with this but in the denominator. So I'm going to rewrite this as I to the 4th, but I need 3 groups of I to the 4th to get 12. Alright, and there's no leftovers. So I to the 4th is 1, and 1 cubed is 1, so this just equals 1. Again, we see that 12 is just a multiple of 4, and that's why it worked out that way. Okay. So now that we understand a little bit more about how these i's, these imaginary numbers work, let's go ahead and start kind of zeroing in on this specific value. Oh, I'm sorry. This should look like this, or either one really. They're the same thing. All right. So we're going to zero in on this and start applying the value of I specifically. Okay. So let's take a look at this next example. We have the square root of negative 36. If this were the square root of 36, this would be really simple for us. But what we're going to do is we're going to rewrite this. All the laws, all the properties of radicals still apply. So I can rewrite this as negative 1 times 36 this way. All right, and the reason that I want to do that is because I know what the value of the square root of negative 1 is. It's I. So here I have I times, and the square root of 36 is just 6. So I times 6. Treat I almost as if it were a variable, so we would write this as 6I. And that's the answer to the square root of negative 36. Let's try the next one. So negative 5 can be rewritten as negative 1 times positive 5. So the square root of negative 1 is I. and I can't take the square root of negative 5, but let me show you how to write this correctly. So we're always going to do something like this. If you're interested in the order, you have regular numbers first, then the I, but last you have radicals. So I always goes between regular numbers and radicals. So here I would have I radical 5. Please don't write this as radical 5I like that. That's incorrect notation. Alright, I goes between the number and the radical. And here technically the number, the coefficient would be 1. We don't have to write it. Alright, in part C, one thing that I really don't want you to do is please don't do a negative times a negative and make that a positive. It doesn't work that way. Alright, so let's keep that negative on the outside. And let's rewrite negative 20 as negative 1 times 20. Alright, so the square root of negative 1 is I, so we have a negative from the outside, and then the square root of negative 1 is I. And then radical 20, I can simplify that. Let's just do that mentally, right? 20 is 4 times 5, and we can take the square root of 4, so that's 2. But square root of 5 cannot be taken, so we have times 2 radical 5. So let's put that together correctly. So I have everything here. I have an I have a coefficient, and I have a radical. So let's pay attention to the correct order of how to do that. Let's do a negative I times 2. We're going to put the coefficient first, so negative 2I, because that's technically really a negative 1. And then our radical. Let's take a look at the very last example for this video. And then we just have some graphing left to do. Alright, so we are going to add or subtract, and then in part B we are going to multiply. So adding, subtracting, multiply, all the things that you've learned before about like terms and distributing and things like that, they work the same way with imaginary numbers. There just might be a little bit more simplifying in the end. So when we are combining like terms, in this case we're adding, we just have to find what's the same, right? So this is a real number, because there's no imaginary number attached to it like in this and this. So these two are like each other and we can combine those. So 2 plus a negative 3, or 2 minus 3, is negative 1. And then we have a positive 3i plus a positive 2i. Treat this as if you were doing 3x plus 2x. It would give us 5x, right? So here we have 5i, positive 5i. A complex number is when you have a mix of a real number and an imaginary number. So this is considered a complex number. You always put the real number first and the imaginary number last. Alright, and then for this one, we're going to distribute. So let's go ahead and start multiplying. So 2 times 4 is 8. 2 times I, although one of these is real and one of these is imaginary, you can still multiply them, just like you could multiply 2 times x, for example. So 2 times I is 2i. Negative 5i times 4 is going to give us negative 20i. And then negative 5i times I, well, I have a negative 5. And then I times I is I squared. Alright, so let's go ahead and simplify that a bit more. So I can combine these right here. So I have 8 plus and 2i minus 20i. Oh, I should have made that a minus. Is negative 18i. And then I have negative 5, but I squared, remember, equals negative 1. So I can simplify that. Actually, I can actually evaluate it. So negative 5i squared is negative 5 times negative 1. So let's simplify that a bit more. 8 minus 18i. And negative 5 times negative 1 is a positive 5. So now I have like terms again. 8 plus 5, we get 13. And then minus 18i. These two are not like terms. So now finally, we have our final answer, which is a complex number. And remember, the real number goes first and the imaginary number goes last.